Okay, so let's take a look at lesson 5.1. We're going to do part 1 today, which is dealing with identifying linear functions. Our objectives are to identify linear functions and linear equations, graph linear functions that represent real-world situations and give their domain and range. This will be more of a day 2, or part 2, I should say, and same with this. We're going to deal with this on part 2, which will be tomorrow. Our vocabulary is a linear function and also linear equation. So let's take a look. We have a graph here, similar to the graphs that we've been working on in class. As you can see, the graph represents a function because each domain value or each x value is paired with exactly one range value or one y value. So you can see my x and my y, 1, 120, 2, 240, and so on. So I have exactly one. The graph is a straight line. Okay, that's important to understand. A function whose graphs form a straight line is called a linear function, which is what we're going to be working on. So we're looking at graphs that are going to form straight lines. They have to have one x to one y and form a straight line for it to be a linear function. So when we look at these graphs, we have 5 graphs here. Remember what we said, that we have to have one x to one y, or our values in order to be linear. So in this case, we have a straight line. We have an x can be -2, and then we have +1. We have a -2, +2, a -2, +3. We have a -2, 0. So what we have is the only domain value is -2, and it's paired with a lot of y values. So again, this would not represent a linear function. It is a straight line, but it's not a linear function. In this case, we can go through and we can look at, we have a point, so we have 2, 3, 4, 5, 0. We have 5, -1. We have 5, -2, or I'm sorry, 3, -2, 4, -1, and so on. So each domain value is paired with exactly one range value. So this graph and the graph forms a line. So yes, it's a linear function. Here, each domain value is paired with exactly one range value. So that's true. We have 0, 0. And as we go through this, we can see that each x has exactly one y. But the graph is not a straight line, so it's not linear. In this case, we have a straight line. So that's the first step. And then we see that we have 4, 4, 3, 4, 2, 4. So we have one x value to exactly one y value. So yes, this is. And here we see that each domain for x, 0, 0, and then if I go to 1, I go to +1, I have 1, -1, so this is not. We learned something last chapter that we could also go through this and look at the vertical line test. And if I were to test this out and draw a vertical line, does it only cross in one spot? Would also tell me if I have a function or not a function. As you can see here, we see that it crosses in more than one spot. Here it crosses in many spots. So we're looking for straight lines that are functions. You can sometimes identify a linear function by looking at a table as well. And there's certain characteristics that we're going to look at on our table. Okay, a list of ordered pairs. In a linear function, we have to have a constant change in x that corresponds to a constant change in y. So this constant change in x has to correspond to the constant change in y. Let's take a look at some examples. So when I look at this table, my x values are -2, -1, 0, 1, and 2. So you can see each time the constant change is +1. It's moving up 1 each time. Over here we start with y, we go 7, then 4, then 1, then -2, then -5. So we also have a constant change. It's going down 3 each time. So 1 to a -3, 1 to a -3, 1 to a -3. You can see these points satisfy a linear function because we have a constant change in x that corresponds to a constant change in y. So it doesn't change. And you can see if we were to graph it and test it out, we see that each x value has a y value and that we have a straight line. So as you can see in this example, we are going up 1 for each of our x values, and we are going in our y values at a different rate. So we go -3, and then we go -1, then we go +1, then we go +3. So we don't have a constant rate between our x and y's that correspond to each other. So these points do not satisfy a linear function because it's not a constant correspondence. If we were to graph these points, we'd also see that we have a curve, and so we don't have a straight line. So because it's not a straight line, it's not linear. All right, so today's assignment or review for lesson 5.1 part 1 is I'd like you to answer the following 2 questions for our next class. Tell whether each set of ordered pairs satisfies a linear function and explain. So you have 2 sets there for question 1 and question 2. You can use either method that we talked about, graphing the points on a coordinate grid and looking to see if it satisfies the characteristics for a linear function, or you can put them in a table and explain that way how you figured out whether or not it satisfies the characteristics for a linear function that way. So please have those done for next class.